Alright guys, welcome to this page of the notes, and again, as promised, we got another one of those problems that you look at and I don't know, it just makes you feel sick. You're like, alright, that's it, time to go home. Not us, alright? We are algebra ninjas. So we're going to go ahead and take care of this problem, and again, keep in mind that process we used on the previous page. You'll recognize the process, sort of the order in which we do things. That order stays the same, even though the problem has changed. Please notice, I have the addition of fractions in the top. I'm going to need to find a common denominator so I can add those guys. I have subtraction of fractions in the bottom. I'll need to find a common denominator so I can subtract those guys. And as promised, these are complicated enough. I'm not going to make them super tricky to find a common denominator. Y and x. Just multiply each fraction by the denominator of the other guy. Same thing down here. So first step is going to be 1 over y, which needs to be multiplied top and bottom by x over x, plus 1 over x, which needs to be multiplied top and bottom by y over y. Again, that's because y and x, the LCM is x, y, right? So that's how I'm going to get it, xy, xy. In the bottom, same thing. Denominator is y, denominator is x. So my LCM is xy. 1 over y times x over x minus 1 over x times y over, oops, sorry, that kind of looks like an x, y over y. Okay, let's go ahead and take care of this then. So what that gives me is 1 times x is x, and that's an xy. 1 times y is y. That'll be an xy, so I wind up with x over xy plus y over xy, all divided by x over xy minus y over xy. Again, right, my LCMs are xy, right? So all my denominators had better be xy's, right? xy's, xy's, xy's. These guys in the top, 1 times x is x, 1 times y is y, 1 times x is x, and 1 times y is y. The only difference is addition in the top, subtraction in the bottom. Now that I have my least common denominator, add the fractions in the top, subtract the fractions in the bottom. So x plus y over xy, all divided by x minus y, all over xy. And once again, just like the problem before, I add the fractions in the top, subtract the fractions in the bottom, and I wind up with a complex rational expression, which we learned how to take care of back in section 1 of this chapter. Right? It's the keep it, change it, flip it from middle school, right? Keep the top, change the division to multiplication, multiply by the reciprocal of the bottom. Let me write it for you right here. X plus y over xy, that's keeping the top. Division becomes multiplication. Take the reciprocal of the bottom. So we flip it. It's going to be xy over x minus y. Well, now that I'm multiplying fractions, cancel, cross cancel if you can. And we can. xy, xy. Reduces to a 1 and a 1. Well, x plus y times 1 is x plus y, and x minus y times 1 is x minus y. Again, infinite number of possibilities here. You do not need to restrict the domain because the variables are being subtracted in this case, and you can come up with an infinite number of possibilities where this would be 0. So you don't have to spend time trying to restrict the domain for me. It's a waste of time. We'll just box our final answer and kind of ignore restricting the domain. So there you go. Hopefully you recognize the process from the previous problem, right? It's the exact same process. Find your LCM, add or subtract fractions in the top, add or subtract fractions in the bottom. It'll get you a complex rational, get you a complex rational expression, which you'll then need to multiply by the reciprocal, and hopefully something will cancel, cross cancel. I've got another one for you on the next page just to, again, really sort of drive home the process you have to go through, even though the problems may look completely different. And hopefully that'll really help you sort of feel more comfortable with when you get to doing these problems on your own. Next page of the notes, I'll meet you guys there.